Universal shift register means, see, some of the shift register normally they use to shift the data from in one direction to another direction, towards another direction. Okay, so that is called what? Unidirectional. Maybe right shifting or towards left shifting. So these type of shifting may be called as unidirectional shift register. Shifting we studied already. Okay, flip flops are used to shift the or to store the memory. Also, they combinedly it is some of the flip flops are working together. It is called a register. So in that one kind of register is called what? Shift register. That also we studied introduction, and 4 kinds of operations also we studied: serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel. 4 kinds of operations using shift register we studied. Now this is about universal. So if it can able to forward the data in one direction, means such shift register is called what? Unidirectional. Or it can able to direct the data in both directions, in the forward and in the backward direction. In such shift register is called what? Bidirectional shift register. Okay. So now what is universal? What is universal shift register? If it can able to do this both the operations, either in forward or in the backward operation, also it can able to do parallel loading operation. Parallel loading and both shifts, forward and backward shift is possible, means such a shift register is called what? Universal shift register. So that is called what? Universal shift register. So how it operates, we are going to see that. So see this diagram. This diagram is very, very important one. Without this, you cannot explain the shift register, universal shift register concept. Okay. But if you understand without seeing this diagram, you can memorize this easily. You can draw it easily. So please listen this. First, we must know the shift register block diagram. See the universal shift register block diagram. Actually, this bigger diagram, no, this bigger diagram only we are specifying this, in the form of block diagram. So what do you have here? See, actually, this portion, no, this portion, no, ma. So this portion only we specified there as, see, whatever I have shown here within the box. This only given here as shift register. So what are the components you have inside? So all this, see, this is what? Flip-flop. D flip-flop we used. Okay, D flip-flop. You can use the, D flip-flop is used. Then the multiplexers are used. Okay, 4 multiplexers also are used. So we are explaining about the, with the use of 4 bits here. Okay, 4-bit data we are taking. And for performing the operation, for the 4-bit data, we are using this circuit. Okay. So these are the components we are having inside this shift register. Okay. Next, in outside, what you are having? See here, S1, S0. These 2 parameters are there, no? S1, S0. So that parameters are given here. See, drawing block diagram is very easy. That parameters are given here, right? Then the clock signal is given. See, since we are using D flip-flop, clock signal also. You see that clock signal you are having here. Okay, externally we are applying the clock signal, right? Then one clear input to reset your flip-flop. All flip-flops. To reset all flip-flops. So reset means what? We have to make the data 0 here. We have to store the data here 0, 0 like that. Okay, all the flip-flops we may have the data 0. So in that manner we can able to clear the all flip-flops, right? Using clear B command, right? Now this is then MSB in, LSB in. So what is this actually? MSB in. See here, serial input for shift right. We are going to give externally. We have to pass the input one by one. That is what serial input here. So to get the input or to pass the input to this circuit, see from this side. When you are passing this side, right side, you can shift it. See, right side, towards right, you can shift it. So that's why you have here MSB in. So input parameter is there. See, LSB in this side. So in the same circuit, if you want to perform left shifting like that. So from this side, you will pass the data, but you need to perform what? Left shifting. See, left shifting like this. Then it is see here this side, no? Serial input for shift left. So in the rightmost side, in the bottom side, see here. Here you are having, no? So there through this line, externally data will be passed. So like that. So all these parameter and this parameter only we are having here and here. So this is what the other components are in the block diagram. Right. So this also clock signal I told, clear also I told. Then external these two inputs we have seen, and this S1 S0 also we are passing. Why I will tell you. See, for S1 S0 to control the operation of this circuit, when you are passing both zeros, no change in the output. 0 1 means it has to perform shift right, and 1 0 means it has to perform shift left, like that. 1 1 means I said no, for universal shift register it will allow parallel loading as well as shifting. Parallel loading as well as shifting this can perform. So that's why it's called as universal shift register, universally accepted register for doing this operations, right? Then see here I pair and the A pair means what about this parameter? See here, input we are passing in parallel. See in the bigger circuit you see parallel inputs we are passing. So 4 bit data you are passing. I0 it is denoted as I0, I1, I2, I3. Am I right, ma? So see here in the block diagram, input in parallel. That slash is actually we are given single line, no, but this slash means one cross line, and 4 it says that you are having 4 lines. See, actually 4 lines are here. Am I right, ma? This is one line, this is another line, this is another one, like that. Okay, 4 lines you are having. So it says that here you are having actually 4 inputs. Okay, that cross 4 means you are having 4 inputs you are passing to the shift register. That is the meaning. 4 inputs you are passing to. So that's why this 4 we are specifying like this. Okay. Now see here 4 outputs now. See 4 output na A parameter. That is the parameter we are using here to receive the output. Parallel outputs. So A pair means A is the output parameter that we are denoting with the parameter A. Pair means what? Parallel. Pair means what? Parallel. So 4 outputs we are receiving from the circuit. So in parallel, when you are doing parallel operations, see here, when you are applying 1 1 in S0 and S1, you have to do the parallel loading and parallel output will be received. So I hope you understood now the block diagram of the given circuit, right? So block diagram of this universal shift register only given here. Now see in this circuit how the operation is. Here we have to use the multiplexer because this multiplexer has, see, it accepts 4 different inputs. It has 4 pins as inputs. Multiplexer we studied in the unit 2. It will accept some input 2 per n, and how many output will be directed? Only one output. Okay, so 2 per n to only one output will be. So that already we studied. Okay, and the selection line also will be there. So in the multiplexer we said about selection lines. Okay, so to 2 power 2 equal to what? 4. So 4 input is there, means 2 number of selection lines will be there. So that 2 only we are having here as S0 and S1, right, ma? And so here what you are doing, see, when your operation is 0 0 means no change. No change means what? You assume that in the flip-flop you are having the data 1 0 1 1 already. You are having the data 1 0 1 1. Okay, what is happening here? Here you assume that you are passing what data now? 0 0 will be you are passing now. Yes, because for the first operation 0 0 0 0 means what is happening? The circuit it selects the 0th pin. See, that same 0 0 will be passed here also. See here, ma? Same line, same S0 S1 line is there. Am I right? Okay, so same 0 0 also will be passed here. Control line, mode of control. So same means what? In all the multiplexers, it has to invoke or it has to select the 0th pin. Understood? The 0th pin. So 0 0 means what? 0, no? It is the binary of the decimal 0. Okay, ma? So this 0th pin will be selected now. Then what will happen? See, this 0th line is connected to this is selected and it will direct the output through this Y. Because that line alone, from that through the selection line, that pin alone will be selected and Y will direct the output to this D flip-flop now. In the D flip-flop, what output you are having actually in the memory? What memory content element you are having in the first flip-flop? 1. Okay. So it will route this 1 here. Because no change, it will route this 1. And that you see why it is routing, why it is directing that data 1 towards output. No, because same line is connected to 0. Okay, so same 1, no. will be directed through the output A3. Right, will be directed through the output A3. Like that here 0, because of the 0, 0, this 0 will be selected and it will route this 0 here. It will route this 1 here. It will route this 1 here. So whatever you had in your memory, whatever you had previously in your memory, same thing will be directed to the output. So that is why we say this is what? See, no change. No change in the output. Right, ma? So just you want to receive the flip-flop outputs from this circuit, you need to pass here that mode control values as 0, 0. Then what is the present flip-flop memory elements will be given to the output side. Okay, will be given to the output side through this 0th pin. Through this 0th pin. Okay. Now what is the second mode of operation? Second mode of operation for S1 0 and for S1 for S1 0 and for S0 1 for 0 1. Okay, 0 1 means what operation the circuit will perform? It will perform shift right. Okay, shift right means actually, so everywhere you are passing the 0 1. See, all the multiplexes 0 1 will be passed. Okay, you take this side also 0 1 will be this side also 0 1 pin will be, because see, it is connected, interconnected. Okay, that S0 S1 line is interconnected here, right? Now, what operation will shift right? Shift right means you need data. Okay, you need to shift data in the right hand side means towards right means that definitely you need data. You have to pass the data external from external side. Okay, so you assume that I want to pass this data now. 1011 now. Understood, ma? 1011 I am passing as output to this circuit now, right? To this shift register. But see here 4 pins are there. What pin to be activated? I don't know. Okay, so that is why this mode control operation, mode control input will be. So 0 1 means shift register will work on, it will direct this first pin. See here pin number 1 is there, no? Here also pin number 1 is there. Pin number 1 is there. So among these 4 pins, based on the 0 1 means 1 no. So this 1, whatever you are having in this 1th pin, see whatever you are having in the 1th pin is connected externally, right, to receive the data. Understood? So like that, see everywhere. So, but this 1th pin is connected with this A3. How I will tell you? See, okay ma, this A3, see. Like that, see here 1th pin is connected with, where it is connected with here. Understood? So like that in this side also. So it is connected with what? A1 like that. Right. So how the shifting will be taken place here? What you are doing, this line will be selected. This one pin 1 is selected now. Okay, that you know. That time this one no, you are putting inside. Okay ma, this one what you are doing, you are putting inside. So this one you are putting inside through this line. So that will be passed through this line Y no. Through this Y it will be passed. Then in the memory D as input to the D flip-flop, that same one will be passed. Then it will be in the memory of this first flip-flop. Okay, it will be in the memory of the first flip-flop. Okay. Now what you are doing, see, you are passing the second bit again. Second bit you are passing. When you are doing the second through the same line, shifting will be carried out. The previous old data, this one no, one will be passed through this. That is called shifting now. The previous data will be passed here and it will be routed through this. So that previous this one you are having here now in this flip-flop. At the same time, in the next clock, that is a clock signal is given. In the next clock signal, what will happen? This one will come inside. Okay ma? The next input will come enter inside. So that time it will be routed through this Y and now the second one you are having here. Okay, in the next clock signal, in the third clock signal again what is happening? The 0 will be passed. Okay, so when you are passing the 0 through the same line, what will happen? This one no, this one will be routed to the next flip-flop. Okay, so that one is here now. That one is here now. This one no, previous input of the A3 means first D flip-flop will be here now. Okay, that also will be routed through this. So you are having the data here. Now the current 0 no, current 0 will be passed here. So the D flip-flop is not having any value. So on that it will be stored. Understood? So that time the previous elements everything will be shifted one position towards right. Understood, ma? Now externally from this one you are bringing in the next clock pulse. Fourth bit you are bringing now. So when you are putting the fourth bit now 1, what is happening? This 0 will be taken here and 0 will be given here. This 1 will be given here. This 1 will be passed towards this. Understood, ma? That 1 is here now. Right? So now what you are having, last 1 will be routed here now. Okay, so see here the flip-flop contents now. See the flip-flop contents, see here now. Understood? This only you wanted to pass through this circuit, no? So that 1 0 1 1. Now you need to get this output in parallel, means through this line you can take it out. This 1, this 0 you can take it through this. This 1 you can take it through this. So this 1 you. So finally 1 0 1 1. This only I decided to give now 1 0 1 1 only I have decided to give now. But what shifting I performed here? Shift right I performed. Understood, ma? So this is the scenario now. Now see here S1 S0. S1 is 1. S0 is 0. So what operation I am performing now? This 1 0. What operation the circuit has to perform? Shift left. How do I know shift left now? Because 1 0 means 2. 1 0 means what? 2. Means second pin need to be activated. Means selected. Second pin. So here also second pin need to be. Am I right, ma? But in the second pin, see here. In the second pin, but in the rightmost side you see. See, second pin only connected with the external input. As I told in the previous case, 1 0 1 1 no. You have to perform now towards left. Towards left shifting will be now. Understood? Because in this side only it is getting the input. Right, ma? So that is why to differentiate that right shifting, left shifting, we are passing the control input here. 0 1 means it will automatically select the pin number 1. 2 means it will select the pin number 2, and that time it will receive the data from the rightmost side. Now tell me, so what is happening here? This 1 will be passed now. See, that is why so this 1 will be na. So this 1 will be first passed. So when you are passing this 1, what will happen? When you are passing this to this 1, it will be given to the next one based on the shifting in the next clock signal. Understood, ma? So this is happening now. Right? So as I told in the right hand side, left hand side you should understand. Okay? Left hand side you should understand. So you apply and find it. Third one, fourth one is what? 1 1. So 1 1 you take 1 1. So when you are passing 1 1, what will happen? See, third pin will be activated. Third pin will be activated. Am I right, ma? Okay, in all the multiplexers, third pin will be activated now, means selected. So when you are selecting where it is connected now, see, it is connected with I3, I2, it is connected with I1, it is connected with I0. So that time, directly, so parallelly, you are giving input. At the time, you are giving, so 1, 0, 1, 1. Understood? So this data will be taken here, it will be stored here, this 1. Yeah, this 0 will be taken here, it is stored here. This 1 also will be taken, stored here, because it will be directed through this third pin towards Y and to D, from D to Q, from Q to A1. Understood? Then from this 3 it will be given here directly and it will be stored here. Finally, what output you are having? You are having your desired output or not? 1 0 1 1 will be directed towards your output. Right, ma? So this all the operation, right shifting, parallel load and previous data no change operation also you can able to do through this universal shift register. In detail all the operation you have to